Hello everyone, my name is Aditya Niranjan and I'm the student of Bennett University, currently in second year and currently pursuing in second year, third sem, and the topic on which I'm gonna make my video is linear regression. So this topic of machine learning, simple machine learning, and for this I would just like to thank Mr. Umesh sir to just making me this much comfortable and better in this topic, machine learning. So now just let's get started. For machine learning. So our topic is linear regression and we're gonna just discuss this thing. So now let's just get started. So hello everyone, today we'll be looking after linear regression. What is it? So this is what we're gonna discuss today. It is the basic introduction, regression definition, linear regression, scatter graph, slope and intercept, least square method, and some of the examples. And after this, we will be solving as well some of the questions as well to get a better grip on the regression. So to analyze the specific relations between the two or more variables. This is done to gain the information about one through knowing values of the other. So this is the introduction of regression. So it says, as we have already gone through it. So the definition of regression: a statistical measure that attempts to determine the strength of the relationship between one dependent variable and y and a series of other changing variables known as independent variables. Forecast value of a dependent variable by from the value of independent variables. So now just have a regression analysis. In statistics, regression analysis includes many techniques from modeling and analyzing several variables. When the focus is on the relationship between a dependent variable and one or more independent variables, regression analysis is widely used for predicting and forecasting. So this is just regression is used for predicting the values, as it says all. Predicting the dependent variables from the independent variables for the previous given data sets of both. So dependent and independent variables. So what is this? So independent variables are regarded as input to a system and may take on different values freely. And let's talk about dependent variables. Dependent variables are those values that change as a consequence of changes in other values in the system. So independent variable is also called as predictor or explanatory variable, and it is denoted by X. And similarly, dependent variable is also called as response variable, and it is denoted by Y. So independent variable, as the name says, is completely independent. It's not dependent on anything, and what dependent, as its name also says, it's dependent on some of the other factors or variables. And we have listed independent as X and dependent as Y. Linear regression. The simplest mathematical relationship between the two variables x and y is a linear relationship. In a cause and effect relationship, the independent variable is the cause and the dependent variable is the effect. Least squares linear regression is a method for predicting the value of a dependent variable y based on the value of an independent variable x. So this is it. So now we are having a formula, the first order linear model, that is y equal to v0 plus v1 x plus epsilon. So here y is the dependent variable, x is the independent variable, v0 is y-intercept, v1 is the slope, and x is the independent variable, as we know, and is the error. And let's now see what is slope and intercept. As we all know, might be knowing, as we are learning this thing from basic class. So the slope of a line is a change in y from 1 unit increase in x. Y-intercept. It is the height at which the line crosses the vertical axis and is obtaining by setting x equal to 0 in the equation. So now we just look after an example of x and y. So example of a simple linear regression which has one independent variable. Okay, so here we can see where x equal to 0, here is the y-intercept, this will be the y-intercept because here x is the 0 and it is cutting y here, it is the y-intercept, that is a constant. And to know the slope, the angle between this line and x-axis, that is theta, so tan theta gives us the slope, that is m, or in the previous we have taken as x0. Error variable, random error term. The quantity E is the model equation is a random variable assumed to be normally distributed with E equal to 0, V equal to sigma square. E random deviate or random error term. Without E, any observed pair x, y would correspond to a point falling exactly on the line y equal to v0, v1x called to regression line. So basically without error, the predicted values will be directly equivalent to actual values because there is no error. So as there is always some error, there are very rarely cases, I mean 0.001, some cases there might be where there is no error, but there is usually error. So here the variable comes in E, and if there is no error, then it is just completely equivalent to the original values. The inclusion of the random error term allows x, y to fall either above the true regression line or below the line. So when E is greater than 0, epsilon is greater than 0, means the error is on positive side, the predicted values will be greater than the actual values. So the slope will be on the, the line will be on the upper side because the actual values are greater than the predicted, are lesser than the predicted values. So the actual line will be below and the predicted values will be above the actual line. Where in case of when E is less than 0, that means the predicted values are less than actual values. This is when the error is negative. So in this case, the predicted line will be below as the actual line is, and the actual line will be above of the predicted line. This is because the actual value is greater than the predicted value. So scatter plot. Now let's just define a scatter plot. Scatter plot or a scatter graph is a type of mathematical diagram to display values for two variables for a set of data. A scatter plot is a graph made by plotting ordered pair in a coordinate plane to show the correlation between the two sets of data. The data is displayed as a collection of points. Okay. This is more information about scatter plot. A scatter plot describes a positive trend if as one set of value increases, the other set tends to increase. So in this is the case of when the slope is on a positive side. So when one is increasing, the other will be increasing. So if x is increasing, y will increase, and vice versa as well. Y is increasing. The scatter plot describes a negative trend if as one set of value increases, the other set tends to decrease. So this is an example of a negative trend when slope is negative. Basically, when x is increasing, y is decreasing, or y is increasing, x is decreasing. So this is in the case of a negative slope. The position on the vertical axis. This kind of plot is called a scatter chart, scatter graph, scatter diagram, or a scatter graph. So now this is the example of scatter graph. Here is the independent variables, dependent variable, that is response variable, explanatory variable, and the different values corresponding to x and y, independent and dependent variables. So now we'll be looking for least square estimation, that is V0 and V1. V0 equal to mean response when x equal to 0, y-intercept. V1 change in mean response when x increases by 1 unit. V0, V1 are unknown parameters like mu. b0 plus b1x equal to mean response when extended variable takes on the value x. Goal to choose values that minimize the sum of squared errors of observed values to the straight line. So as we have seen that b0 is a response, y-intercept, b1 the slope, unknown parameters, b0 plus b1x, mean response when experimental variable takes on the value x. Okay, so here is the predicted value y equal to v0 plus b1x. Here is the squared errors. So squared errors is the summation of the difference between the actual price or actual data minus the predicted data square. So it is the square of difference between the actual data minus predicted data, and we are just summing it up, and we are replacing this y hat with this value as if both are same. We get this thing. The least square estimate of the slope coefficient b1 of true regression line is b1 equal to summation of xi minus x dash into yi minus y dash divided by summation of xi minus x dash whole square. The least square estimate of the intercept b0 of true regression line is b0 equal to y dash minus b1 x dash. Regression generates what is called least square regression line. The regression line takes the form of a plus bx, where a and b are both constants. Pronounced y hat is the predicted value of y and x is the specific value of independent variable. Basically, a is the constant, that is y-intercept, and b is the other constant, that is the slope. Such a formula could be used to generate values for a given value of x. For example, suppose a equal to 10 and b equal to 7. If x is 10, then the formula produces a predicted value for y of 45 from 10 plus 5 into 7, obviously. It turns out that with any two variables x and y, there is one equation that produces the best fit linking x to y. Absolutely. We use the criteria is called the least squares criterion to measure the best. So now we can imagine a formula that produces prediction for y for each value of x in the data. Those predictions which will usually differ from the actual value of y that is being predicted, unless the y values lie exactly on a straight line. Obviously, if you square the difference and add up the square difference across the prediction, we get a number called the residual or error sum or squares. The formula above is simply the mathematical representation of squared errors. Regression generates a formula such that square error is as small as it can be possibly be. Minimizing this number by using calculus minimizes the average error in prediction. We'll be going through this via question, so we'll be able to understand this thing better. So this is the example, the independent variable. The dependent variable, independent is the temperature and how it is affecting the sales. So as we see, as the temperature is increasing, the sales are increasing. Till 92 the sale is the maximum, and afterwards, till 98, 100. So 100 is the maximum value, and the sales are maximum in the case of 98. Sales are maximum in the case of 98, and the sales then goes down as the temperature is going down. Ice cream sales. So this is one or other data set, and they have made a plot graph, and if you want to predict any value between this thing, so it will be just simple. If we just suppose if we want to predict the value of 100, so we need to just plot it just above. I think 100 is this one. If we want to predict the value of 90, it will be somewhere here. 90 will be somewhere here, 99 will be somewhere here. So using this graph, we can directly get the values. Most applications of linear regression. If the goal is prediction or forecasting, linear regression can be used to fit a predictive model to an observed data set of y and x values. After developing such a model, if an additional value of x is then given without its accompanying value of y, then the fitted model can be used to make a prediction of the value y. Given a variable y and a number of variables x1, x2 till xp that may be related to y, linear regression analysis can be applied to quantify the strength of relationship between y and the xj, to access which xj may have no relationship with y at all, and to identify which subsets of xj contain redundant information about y. And that's all in the PPT. So now we'll be just looking after a question and how we're going to solve it. So this is the basic thing, actual point and the predicted one. So A will be the actual point and A dash will be the predicted point. So in this, if we see the actual point and predicted point, the actual point, the predicted point, okay, we will be skipping this, we will be just directly going. How we gonna be solving it? Just we'll be going for hypothesis function first. We'll be taking y equal to mx, which can be also written as h theta x of theta naught x, where theta naught will be the slope, theta 1 will be the y-intercept, and this will be the value of dependent variable, the independent variable, and we'll be then finding cost function. So cost function is minimizing minimum square estimation, minimum square distance for linear regression. So just we'll directly go for another question. Data set, here it is the area, here is the price, and suppose the independent variable 4 square is given, but we are not having the price for it. Now we need to find it. So just we'll be taking an example, we'll be taking a case. So considering the first slope as theta naught, the slope as 0.5 and intercept as 0, we need to just predict, we cannot take any random variable value as we have taken for this graph. If you see, this is the predicted value and this is the actual value. So we have taken this case where theta naught is 0.5 and intercept is 0. So in this, the function of the line will be something like theta naught x plus theta 1, where if we put the value of theta naught and theta 1, we get y equal to 0.5 of x, which can be also h of theta x. So for x equal to 1, we are just computing the different values of y with the help of this equation, line equation, and we get the values. Now we'll be using cost function, that is minimum square error or estimation, minimum square error or distance given, we can say that is 1 by 2n summation of the square of difference between the actual minus the predicted one. So here is the predicted one minus the actual one, predicted one minus the actual one. As in case of x equal to 1, the predicted was 0 but the real value was 1. The predicted was 1 in the case of x equal to 2 and the original actual value was 2. So now we'll be computing it and we got it as 0.58. Now we'll be checking for idle case when theta not equal to 1 and theta equal to 0. So in this case, as it's clearly visible, the difference will be 0. So 0 into something will always be 0. So in this case, we got minimum square distance as 0. So as the one with the minimum square distance is the best possible answer. So in this case, we just directly went in. This was a really simple case where it's directly visible for us that this is going to be the best possible case. But if it is a bit complex, then it's not visible for us. Then how many cases we'll be taking, how further we'll be just comparing the minimum square distance of different cases. So this is one of the questions. So and the solution is gradient slope descent. We'll comparing on the basis of gradient slope. Algorithm for gradient descent on one line algorithm. So we'll be using the convergence. So when the cost function is converging, means it is going from negative to positive. Converging means the slope is changing from negative to positive or positive to negative. So when the slope is changing from negative to positive, we'll be saying it is converging. So we'll be going with the formula and we'll be deriving it. So this is the formula. Repeat until convergence. repeat until convergence. So this is for slope theta j equal to theta j minus alpha into derivation of theta this one, derivation of this formula. So and for the constant one also, it will be constant equal to constant minus alpha or derivation of that constant variable, like this thing, theta 1, theta naught. So we need to repeat until it is converging. I mean, it's not getting from not changing its slope, like converging. See here, the slope was negative. Now it has become positive. So we'll be repeating until then. Linear regression using gradient descent. So here they are derivating. Here we are derivating. So we get the derivation as derivation as 1 by s summation of the hx h theta of x minus y. So this is the formula, theta naught equal to minus alpha 1 by n summation of I equal to 1 to n theta h theta x minus y into xi, and this is the similar the formula of intercept as well, and it goes on. If not using gradient descent, then we can compute the slope as xi minus x mean into yi minus y mean divided by xi minus x mean square, and intercept equal to y mean minus slope into x mean. So if we don't want to use gradient descent, then this is we can say a shortcut method for this thing, where slope the formula of slope is just similar as we have learned in the smaller classes, like y2 minus y1 divided by x2 minus x1. So in this case as well, see, if we see here, xi minus x mean will be getting cutted from upper and bottom, so it will be x2 minus x1 divided by y2 minus y1 divided by x2 minus x1, and the constant that we have seen the intercept here, same formula, and we can get the values. So thank you for watching this video. If there's any question, just write in the comment box. I'll try my best to answer the question. And it's not big, it's just a simple topic, not much complicated. Yes, but it might get lengthy for some of the questions. So everyone, thank you for watching this video. If you like it, please like the video. Comment down if there is any doubt related to this topic. I will try my best to help you out. And if you find this video helpful, you can just share it as well, the video as well. And thank you everyone for watching this video. From this only, I would just like to end this video. Thank you everyone.